We are on. We're live. Okay, good. 4:19:21. Okay, so our objective today is using the law of cosines. So we got a lot of sines. We've got a lot of cosines, and there is a law of tangent, but nobody uses it. Okay, a law of tangents just completely worthless. Okay, so we will not learn the law of tangents. Okay, there is such a thing though, of course. Now before we start, let's just draw any old triangle. Okay, don't draw a right triangle, just draw any old triangle. Okay, so if you know side, angle, side, okay? So if you know side, angle, side, what does that mean? Well, if I know side and an angle and another side, okay? I do not have opposites, do I? If that's all I know, there's no opposites, okay? So you cannot use the law of sines because there's no opposites. So you have to have a new thing called the law of cosines. Now we can find an opposite by the law of cosines. So if you know side, angle, side, the law of cosines says this: opposite squared is equal to my adjacent squared plus my other adjacent squared minus 2, and 2 is in the formula. 2 is always in the formula. 2 times my adjacent times my other adjacent times the cosine of theta. See, I told you it was a long formula, right? But it's not hard. And then the next step you're going to do is just take the square root of that answer because it's opposite squared. So then you'll say the opposite is going to equal the square root of that answer. Does that make sense? Because you've got opposite squared. You put all of this into your calculator. You hit enter, boom, you get a number, but then you have to take the square root of that because it's opposite squared, okay? All right, here we go. Make sure that's times. This is where kids mess up. You guys won't mess up. Make sure that's a plus, and these are times and times, okay? And that's a times. All right, so let's take a look at example 1. I do have side, angle, side, don't I? I have side, angle, side. I do not have a pair of opposites, okay? So I'm going to set it up as this. So if this is angle C here, we can find side C because that's my opposite side, okay? I have side, angle, side. If I have side, angle, side, I can find the opposite side by the law of cosine. So I'm going to set it up like this. This is opposite squared. That's C. Am I going too fast or am I okay? Am I okay? Good. Thank you, Faith. So that's my opposite side, so I'm going to go C squared equals, okay? Well, adjacent squared. It doesn't really matter which one. So I'll go 12 squared plus 13 squared. Subtract 2 times 12 times 13 times the cosine of 54 degrees, okay? All right, it's kind of a long formula, but I'm just going to put that in my calculator just like that. I'm just going to put the whole thing in there. Then I'll push enter, then I'll push square root, okay? I'll put it all in there, okay? So I'm going to go 12 squared plus 13 squared minus 2 times 12 times 13 times the cosine of 54 degrees, okay? Boom. All right, now, so then I've got C squared equals 129.61 blah, blah, blah. And of course, then I'm just going to take the square root of that, and I will get the value of C. So square root of that answer, right, because that's just the answer button makes it faster. About 13.4, okay, we'll run, or 11.4, okay? So C is about 11.4. How's that? Not too bad? Thumbs up, you guys? So it's not a bad formula. It's actually pretty easy. It's just long. Now, the law of cosines can also be used to find an angle. So and now I don't want you to write this down, but really technically, if you look at this formula here, cosine of theta is in it. If you isolate the cosine of theta, you'll get a formula for solving for an angle, okay? So that's what I'm going to give you. I'm going to give you the formula, okay? So if you know, side, okay? If you know side, you can find theta by the law of cosines, okay? So the law of cosines is this. You ready? It's going to be this formula, but with cosine solved. Does that make sense? But I'm going to do it for you. So it's going to be cosine theta equals parentheses. And the parentheses are super important for your calculator because you're going to have the entire top divided by the entire bottom, okay? It's going to be adjacent squared plus the other adjacent squared minus the opposite squared, parentheses, the parentheses are super important, divided by parentheses 2 times the adjacent times the other adjacent. Sorry guys, okay, there it is. So all I did is I took our formula above and I solved it. Now the last thing I have to do, since it says cosine of theta, we'll have to take the cosine inverse. That makes sense. We're going to get this blah, blah, blah. We're going to get a decimal, but then we're also going to have to do cosine inverse of our answer, okay? That's the last step. So here we go. Let's find angle R. If there's ever an obtuse angle, find that first. And I think we saw why that works over the last week, remember? Sometimes with the obtuse angle, you can mess up. So I'm going to find angle R. All right, so I'm going to set angle R up. So I'm going to go cosine of R equals, well, I'm using this formula here. There you go. I'm going to go equals parentheses. Well, if I look at this, here's my adjacent, here's my other adjacent, and that makes the 6.2 the opposite. You guys agree with that? All right, so if I pick angle R, 3.1, 4.5 are my adjacent sides, and it makes my 6.2 my opposite side. So I'm just going to plug these numbers into the formula. That's all. So I'll go 3.1, 4.5, 6.2 here, and 3.1 and 4.5 here. All right, so I'm going to go cosine of R is equal to adjacent squared, 3.1 squared, plus the other adjacent squared, okay, which is going to be, oh, let's just say squared. I don't know why it says 2. 4.5 squared. Subtract my opposite squared, which is 6.2 squared, parentheses, divided by parentheses. I am now going to go my 2 times my adjacent, which is my 3.1, times my other adjacent, which is my 4.5, parentheses. And now I'm just going to put that in my calculus. Okay, now I'm going to emphasize again the parentheses are really important. And you guys are smart. You know why they're important. I need the entire top of this to be divided by the entire bottom. If I don't use the parentheses in my calculator, it's going to mess up, right? Okay, so here we go. I'm going to go ahead and put this in. So let's go parentheses. You have to have parentheses, okay? 3.1 squared plus, whoop, minus 6.2 squared parentheses divided by parentheses 2 times 3.1 times 4.5 parentheses. Okay, how am I doing? Okay, and now if I push in, I'm hoping for a decimal. I mean, if I don't get a decimal, I'm going to be surprised because I'm going to cosine it, inverse it. Okay, I get a decimal. That makes a lot of sense to me because I want to go the cosine inverse of that. We're going to learn next chapter why these are decimals. Okay, that's next chapter is to understand why trig works. So cosine inverse of that answer, okay? And I like the answer button because I don't have to retype that button. And I get an answer of 107.9. Does that answer make sense? Yeah, that could be 107.9 degrees. Right, everybody agree with that? Okay, now, example 3 says solve this triangle. Well, if I want to solve this triangle, at this point I have two choices. I need to find angle S and angle Q, okay? Spencer, you like the law of sines, don't you? Right? It's easier. The law of cosines will work. You could find angle S by this formula. You could. Or you can find angle Q with this formula. But we also have the law of sines, because once you have a pair of opposites, why not use the easy one? Does that make sense? Yeah. So if I've got my opposites, right, let's just use the law of sines. It's easier, okay? So, all right. Chloe, what do you want to find? Angle Q or angle S? Does not matter to me. Angle S. So if we find angle S, then all of a sudden this becomes its opposite side, right? Law of sines, opposite, 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 opposite. So we'll say sine of angle S over its opposite side equals the sine of 107.9 over its opposite side, okay? And then we'll multiply up to 3.1. So we've got sine of S is equal to 3.1 times the sine of 107.9 divided by 6.2. Hopefully I'll get a decimal because I'm going to sine inverse that. Yes, Spencer? Yeah, go ahead. Yeah. So we'll go 3.1 times sine of 107.9, close parentheses. Oops, close. Didn't I say close parentheses? Divided by 6.2. I'm expecting a decimal. I do get a decimal because I'm going to sine inverse that, right? Inverse that decimal. Sine inverse that answer. And I give it a 28.4 degree angle. That looks like it could be about 28.4 degrees. Okay, that makes sense to me. Okay. And now, then finally getting angle Q. So this is 28.4. Angle Q is easy. How do I find angle Q? Zoe, how do I find angle Q? Yeah. So angle Q is equal to 180 degrees minus the sum of 107.9 and 28.4. And I've got the triangle solved. Okay. Now I'm going to go 180 minus the sum of 107.9 plus 28.4. Oops, 4. I can answer about 43.7. Angle Q, 43.7. Okay, how am I doing? Am I doing okay? Am I doing okay? Trick's not hard. Okay, let's see what's on the back side. All right. Okay, I got a triangle within a triangle, huh? I want to find AD. All right. I want to find AD, which is right here. Just call that X right now. So here's how I think I'm going to tackle it. Finding AD. Well, I could find angle B, because I could have a side, side, side. Once I get angle B, then I could find this side by the law of cosines. So this is going to take two things. Okay, before I do anything, take a look at the big triangle. So what I have to do first is get this angle. Once I get this angle from the big triangle, I can get X using law of cosines to get AD. Okay, so here's how I'm going to tackle this problem. First, let's use B. Now, of course, if I have side, 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 and of course this side here is 6, right? So, again, if I know side, 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 I can use this formula, okay? Okay, so I'm going to go cosine of B is equal to adjacent. Well, that would be a 6 squared plus the other adjacent. That's a 5 squared minus the opposite, because that'd be the opposite. divided by 2 times my adjacent times my other adjacent. Okay, so I want to find angle B first before I can get the value of AD, okay? All right, so let's see here. I'm going to go ahead and I go, okay, parentheses 6 squared plus 5 squared minus 7 squared divided by parentheses 2 times 6 times 5, and I get a decimal. Hope for 0.2, okay? And I'll cosine inverse that, right? So I'll go cosine inverse of my 0.2. I can do cosine inverse of that answer. So I get about 78.5 for angle B. I'm going to write that in there, 78.5. Okay, now I can get AD because I'll have my side angle side. But now I'm going to use the inside triangle. So I'm going to use this smaller triangle. It's my blue triangle. And I'll tackle that. So, okay, also, if I have side angle side, I'm going to use this. I'm going to use this formula. So I'll set it up as opposite squared equals adjacent squared, which is 2, plus adjacent squared, which is 5, minus 2 times my adjacent, which is also 2, times 5, which is my other adjacent, times the cosine of 78.5. Okay? Am I doing okay? Am I making sense? Am I not going too fast? So then I'm going to go, okay, we'll go 2 squared plus 5 squared minus 2 times, 2 times 2 times 5 times the cosine of 78.5, okay? And then I'm going to take the square root of that, because it's x squared, right? So I get x squared equals my 25. Take the square root of that, it's probably about 5, right? So it means AD should have been about 5. How am I doing? And when are we out of here in 28? Okay, so I don't think I'll do example 4. I think we're going to run out of time to do example 4, but I will set you up and I'll show you what I would do on example 4. Oh no, I've got time. 128, I got time to do it. I got 8 minutes. Let's do it. Okay, let's cut this triangle right down the middle, right there, huh? You guys okay with that? And so then first, let's look at this triangle, okay? I know the area of a triangle, we've learned last week, was 1/2 adjacent times adjacent times the sine of the angle. Okay, we learned that last week, okay? That's our area formula. Well, triangle 1, the blue triangle, is easy. Everything's there. 9, 13, 68. We can get that pretty easily. So triangle 1 is just simply going to be a 1/2 13 times 9, or vice versa. It doesn't really matter which comes first, times the sine of 68. All right. 0.5 times 13 times 9 is the sine of 68. I get an answer of about 54.24. Okay. Now, if I can get this side, right, then I'll have at least side, 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 and then I can get an angle, right? So if I can get this side, which I can get this side by the law of cosines, right? Because I get side angle side. So let's call this, I don't know, let's call it C. Why not? So I can't use Pythagoras' theorem. I would agree you cannot use Pythagoras' theorem, right? So I'm going to say, okay, C squared is equal to 13 squared plus 9 squared minus 2 times 13 times 9 times the cosine of 68. Okay, I'm using my formula, law of cosines, right? I have side angle side. And I'm using this formula right here, so I'm using, okay? All right, so 13 squared plus minus 2 times 13 times 9 times the cosine of 68. And I'll square root that answer. Okay, you guys okay? I'll square root that answer. Square root that answer. So, about 12.74. All right. Whew, it's a hard problem, huh? Okay. Now what am I going to do? Well, if I can find this angle here with, again, the law of cosines, right? If I have side, side, side. Love these problems. They're so involved. Let's call it theta, okay? So I'll go cosine of theta equals parentheses. Well, if that's my angle, then these are my two adjacent sides, right? If that's the angle I'm looking for, these are my two adjacent sides, and that's my opposite side, right? So parentheses, and I'm using this formula here, okay? Isn't that formula there? So I'm going to go cosine. So it's going to be adjacent squared plus the other adjacent squared. 10 squared plus 7 squared minus opposite squared, which is my 12.74 squared parentheses, divided by parentheses 2 times 10 times 7, which is 2 in my formula. Adjacent times adjacent. Okay, I better get a decimal because I'm going to cosine inverse it. Parentheses 10 squared plus 7 squared minus 12.74 squared parentheses divided by parentheses 2 times 10 times 12, okay? And I get a decimal. Kind of hoping so, right? Cosine inverse that. Almost done. This is a big problem. I get about 93.2 degrees. Okay, now, finally, triangle 2. If I use this formula for triangle 2, area of triangle 2 is going to be 1/2 10 times 7 sine of 93.2, because this formula says 1/2 adjacent times my other adjacent times the sine of the angle, okay? 0.5 times 10 times 7 times the sine of 93.2. I get about a 34.9. If I add the two areas together, triangle 1 plus triangle 2, I get the total area. So triangle 1 plus triangle 2 is going to equal, I don't know, 54.24 plus 34.9. I get about an 89.14. And I guess centimeters squared. How's that? That was a big problem, huh? I like it. And I didn't leave you much time, did I? I'm pretty good about that, taking up the whole period. If we had a longer periods, you guys, it would be different, right? I like the shorter periods, except for in this class, I wouldn't mind a little bit more time. Stop.